Well, I think we can start. Hello, a warm welcome to all of you. I'm Ursula Arning, head of the Open Science Department from ZBMed, Information Center for Life Sciences. And before we start, we have to go through some privacy policies. Here we are. This event is being recorded, including chat, and the recording will be posted on this link. Microphones have been muted for this event, but if you have any questions or comments, please type this into the chat or Q&A box, and we will come back to them. So now I'm glad to present you and to introduce you to Gulçin Grip. She's chair of the IFLA Academic and Research Library section. Please, Gulçin.
Thank you. Thank you, Ursula. Thank you. Greetings from Australia, where it's 10 p.m. tonight. And I know for some of you it's morning or afternoon. I'm just delighted to welcome everybody. As Ursula said, I'm the chair of the IFLA Academic and Research Library section. This is the first webinar for the year for 2021. So it's wonderful to see so many people registered and attending. IFLA Academic and Research Library section has been organizing very successfully webinars in the last few years. We deal with topics of interest to the profession, and thanks to the insight and initiative of our colleagues, Dr. Reggie Raju from the University of Cape Town and Xin Li from Cornell University, who have been at the forefront, and they have been leading and organizing the IFLA ARL webinars for the last few years. So tonight we have a very important and a very interesting topic on digital preservation, and I know it's close to the hearts of almost all of us. It's such an important topic. And it's just wonderful that we have these two wonderful speakers from Germany. And thanks to Ursula, one of our members who was able to invite her colleagues, Uta and Katarina, to come and speak to us tonight. IFLA Academic and Research Library section has a very interesting membership from all over the world. As I said, I'm from Australia. We have colleagues from Africa, from California, from Chile, from Hong Kong, you name it, from all over the world. But we do not only webinars, but also have many other activities like blogs. We have a monthly blog. Every month, one of our members writes on a very interesting topic. So go and have a look at our website. We have Facebook presence. We have Twitter presence. And in addition to that, we have other activities that we organize. And you're most welcome to attend our meetings, which we make available via Zoom, so anybody can come attend our talks. So as I said, we are very diverse, we are very inclusive. We welcome anybody to come and join us. We talk, we debate, we plan, we deliver. So tonight's webinar is a wonderful example of the activities that we do. I'm not going to take too much of your time, but before I say thank you to you for joining tonight's webinar, I want to thank especially Reggie and Xin and Ursula and our wonderful speakers, Uta and Katarina, of course, and Sean from Cornell, who is helping us with the technology. So I'm looking forward to watching the webinar. Thank you, everybody.
Thank you, Gulçin, for your introduction. And now I'm glad to present my colleagues, Dr. Katarina Markus, head of our digital long-term preservation team, and her colleague Uta Pamaxis, part of this team. Katarina studied biology in Bonn and then changed tracks to train as a librarian for 2 years. And Uta started as librarian at ZBMed in the acquisition department, managing e-journals and consortial licenses for several years. In 2019, she changed to support research data in digital long-term preservation at ZBMed and is now part of our open science department. And now I wish all of us a very interesting talk And thanks you both for comparting your ideas with us.
Thank you very much for the nice introduction. I start first because we've prepared a little survey because we are interested to understand first of the great audience, just the 130 who logged in, which is very impressive to say the least. So we have prepared 2 short surveys with just 2 questions, so it's not too long, and would ask you kindly to take part and answer to it. It's anonymous. And we will start with the first one now before the first presentation. And we'll conduct maybe the second one if there's still time at the end, we will see. So we will post now the link to the survey page in the chat along with the code. Please enter the code on the website. And then you can start and fill in the survey. After 3 minutes, we will share the results and have a look at it together to start off. Thank you very much for participating.
Okay, so I hope everyone can see the link. I posted it into the chat.
I saw the link and let's see.
Okay, I can post it again.
Yeah, you just posted again. Oh, Katerina, you need to post select to audience and panelists. You just posted to the panelists. You need to select the 2. Do you see that?
But
so
now I receive the chat, all discussion.
Can I also suggest that we say the link is www.menti.com.
okay, I found it again. So I hope now it's in the right part of the chat. Okay.
Sorry for that one.
There's always something you haven't checked before, and then you have to try during the presentation. Okay, and I also shared my screen, so we should see the live results from the survey. If it's not working, then maybe Uta has to look into.
Perhaps you can say the numbers again because it's difficult to copy paste.
Okay, the numbers. You can probably see this now. So the code is this.
I think maybe leave this here for a minute or so because people need time to go there anyway, and then we can put Uta's results on.
Yes. So there are already 34 votes, so it's coming up.
It's actually not showing in the results, so maybe we need a new link.
Yes, I will share it later from my screen, maybe better. So we are now by 50.
Among the audience, I saw someone raised a hand, but because I need to scroll through 128 people, would the audience friend perhaps enter your question in the chat? That's easier for us to monitor. Thank you.
So now it's about half of the people. Maybe we just wait 30 seconds still and then continue with the presentation.
Okay, then I will stop my screen sharing.
Okay.
This is very interactive.
Yes. It's very tempting to already tell the results, but I'm just waiting still.
But perhaps you can start because we have so little time with the presentation,
Yes.
and then we can go back to the.
Okay. Just a second. Okay. So now it comes. Can you see? This is
Yes, perfect.
Okay, so most people attending here are actually involved in some case in digital preservation. That's good to know, because then we can go a little bit more into detail. But of course, we also be aware of the people who are new to digital preservation. And a lot of you are also planning to use digital preservation. Okay, so it's good to have an introduction. That's good, because we do have an introductory part of the presentation. And the second survey results. Okay, so most of you are new and know this about it theoretically, and very little experts. This will be an interesting discussion at the end, because I think the questions will be very different if you have knowledge before about digital preservation, or if you're starting very new, and if you only have theoretical knowledge. Okay, so now to the presentation. So I will share my screen again. Okay. So yeah, welcome to our presentation, and thanks to everyone for the nice introduction. And I will start with part one. So I will do a general introduction into digital preservation. And the first question is, why do we actually need digital preservation? And the answer is, we keep losing digital content or digital information. There's several different cases shown here, and you might recognize the one on the middle, at the lower part of the slide. You cannot open a file, there's some kind of error. You might also recognize the one on the lower right, the case where you can't use content usually rendered by Adobe Flash Player, because Adobe Flash Player was discontinued at the end of last year. Then there are also several different other cases, like a survey about databases in biology, and the survey found, or the analysis found, that after 18 years, most of those databases were dead. That means not usable anymore. Well known in the digital preservation community is the case of the moon landing tapes, and these the information on these tapes was lost because they were overwritten, just as a part of the, or very likely overwritten as a part of the normal workflow. And on the lower left, there's a image of some kind of data, but you can't use it because it's missing crucial metadata. That's these are all cases of loss of information. And to have a model in order to prevent these losses of preservation, we have 3 different preservation levels. So the first level is the bitstream preservation. This is also the easiest to use, and it preserves a physical integrity of the object, preventing this case with the error, or allowing you to repair. And the solutions are new hardware backups or checksums. Checksums are a combination of unique letters and numbers that are specific to this file. And if the file is altered in any way, even on the most basic technical level, the checksum is altered as well. So this is a kind of checking whether the file is corrupted in any way. The second level is the content preservation, preserving technical reusability. In case of the Adobe Flash Player, you can emulate a computer environment in some case, like virtual machines, and you can use the content still in this emulation environment. Another solution is migration of, for example, easier to handle files like text files and image files. Migration is migration to a new format. So if you know that the format is soon to be obsolete, you can migrate your files to a current format. And the third level is data curation. You can also call it semantic preservation. And it preserves the intellectual reusability. You might recognize it from research data and fair data principles. That means you have sufficient metadata in order to understand the content. But these cases were not covered. The loss of database, or the loss of information from the databases in biology is due to loss of funding, or the case of the moon landing tapes is due to no one defined that these were worth for preservation, and the responsibilities were also unclear. So management is an important part of digital preservation. And on the conceptual level, management also answers these very basic and important questions. What do you want to preserve? Who is responsible? How is the basic preservation done? Of course, from whom do you get the objects is related to the what. And finally, what is your target community? For whom are you doing preservation? And these are also questions, if you have a preservation policy, that's answered in a preservation policy. And it does make sense to just sit down and discuss these questions related to maybe the institutional strategy in order to define what you want to do, and where you archive wants to go to. Well, yeah, what's your focus? In a very simplified manner, so These questions are also answered by the Open Archival Information System standard. This standard is very complex, and this graphic is a very simplified version of it. But it also defines specific steps and entities that are crucial to an archive. And this standard is the standard of the digital preservation community. So most archives use this standard. And you have the archive here as the red box. Outside the archive is the data producer, the management, who does the very strategic decisions, and the target community or the consumer. You have the administration entity that's overseeing the day-to-day work. The uptake into the archive is the ingest step. Data management is something related to mostly metadata, for example, how to find your objects again inside the archive. Archival storage is some kind of also an entity, and for example, the system you have in order to have a search function, for example, if you need to find your objects, and access is of course making the objects accessible to the consumer in case they need the objects. We have at ZBMIT a dark archive, so our direct consumers or target community are publication platforms. But you also have to keep in mind that you are doing preservation for some kind of scientific target community. And finally, we also have down here the preservation planning entity. This is, for example, making preservation plans, like workflows for specific objects that are checked for quality, for repair, necessary repair mechanisms, and so on. So this was very conceptual, but in practice, we also have these three different basic concepts. The already mentioned technology, like maybe migration, the organization, that's also related to the mentioned management, and finally resources, because digital preservation actually does need more resources than you might expect. It's not just backups, because it also needs human resources and lots of financials. So it makes sense to have some kind of cooperations regarding sharing the burden of digital preservation, in the sense that no institution can preserve everything. And also sharing digital technical solutions and expertise. With regard to sharing the burden, there's distributed preservation of licensed and open access content. For example, the Keepers Registry has information from institutions worldwide about preserved journals and who is doing the preservation. They get information from several different institutions, among them the Global LOCKSS Network, CLOCKSS, and Portico. The Global LOCKSS Network is an international community set up from different institutions that use the LOCKSS software, and this LOCKSS software connects the different institutions and can check whether someone is losing some kind of material, and then it can be supplied from another institution with an agreement, of course, with the publishers. This is a bit more complicated than I explained it, but I don't have enough time to go into detail. CLOCKSS also uses the software, and it's more of a preservation service. It has a philosophy, also in agreement with publishers, that in case the content is lost from the publisher's homepage, then it is made automatically open access. Particle is also a preservation service, a non-profit, the same as clocks, and it's member restricted. So some of the content from, in case it's not available from the publisher platform anymore, is open access, but some is also only available to members. And we compared our holdings to a list obtained by Keepers Registry, and we saw that most of our licensed journals are covered by Particle, so we are part now of a Particle consortium. Another way of cooperation is sharing of expertise, and we do that with two other central subject libraries from Germany, the TAB and ZBW. We share the infrastructure, so the digital preservation software system. TAB hosts it and administrates it as well. And we also share expertise in that we have regular meetings and discuss challenges, solutions, and so on. It's always important to have an eye on the national networks in digital preservation, like in Germany, it's Nestor. And the Digital Preservation Coalition is also well established, and there are several different conferences like IFLA, which you can also attend. And sharing of technical solutions, because the technical issues are really challenging, is also important. So there are digital preservation software on the market. There's open source solution, Archive Multica, for example, or we use the commercial Zeta software as our free library cooperation. It's important to keep in mind that these softwares should be OAIS compliant, and it really helps if they have an international community which you can discuss very specific technical challenges. And outside of these software solutions, there are also plugins or tools that can help you with very specific challenges as well. Some of those are maintained by the Preservation Foundation, and some of them are also maintained by the National Archives. The National Archives also maintains, with support of the international community, the technical format registry PRONOME. And to just give an example what these different tools can do. So with regard to risk management and preservation action, you have the ingest step of taking up objects into the archive. And Rosetta, for example, checks for the object integrity if the object comes with a checksum. So if you have a checksum generator, you can generate a checksum. And if it's during the ingest, for example, changed in any way, the object, or even before that, this is recognized during ingest. You can also check for the format. The Droid plugin does that automatically, and it uses the format registry PRONOME for that as a database. And the Drove plugin also checks the validity of the object. That means it checks if the object adheres to the format rules. It really makes sense to check these things during ingest, because if there's some kind of problem, you can still contact optimally the data producer. If you have these objects for 10, 20 years inside the archive and discover some kind of technical or format issue afterwards, it's really difficult to maybe get a new version of the file. Then inside the archive, there are checkups running, and you can decide on a preservation action. For example, regarding object integrity again, but also if the format is at risk, you have to take preservation action in some way. Recognizing that the format is at risk at all is difficult because you have maybe a lot of different formats, and therefore it's interesting to have an internationally maintained format library. In case of Rosetta, this is maintained by the Rosetta community, or more specifically by one working group. And then you can take some action, like migration or repair. This is also, you might also need a tool for something, and you can check the tool registry copter in order to find something that allows you the action you want to do. And you also have to decide on a lot of different things. Digital preservation is not perfect necessarily, or it is definitely not perfect. Sometimes you want to migrate and you're using a little bit of information from the file, but it's better than not migrating at all, because then you would not be able to use the file at all anymore. So this is kind of, yeah, the decision the digital preservation and the archivists have to do, already doing ingest, but as well doing inside the archive. And finally, another step is the pre-ingest. So you have to prepare your object to be compatible with your software. And in our case at ZBMed, we also have this, or we are preparing to have this automated, because if you have a lot of different objects, this is also a lot of work and you can't do everything manually. So we have a application that is programmed at the moment. Finally, documentation is also really important. Documenting your workflows, documenting your decisions, and information documentation via metadata standards for descriptive metadata. So you can find your objects in the archive again. We use Dublin Core for preservation-specific metadata standard. We use premise as is the norm in the digital preservation community. And you can see on the right that a premise data model, it has different entities regarding the object. One, environment might be the software. Right statement is really important, because if you don't have the copyright regarding archival rights or migration rights, it's really difficult to do digital preservation. The agent might be a software, a tool, or a person that's doing something to the object, and the doing is the event. That means, for example, a migration. And everything, or most of the metadata that is documented in premise is documented automatically by Rosetta in our case, but not everything. And finally, at the end, so the conclusion, I'm using the certification for the conclusion, because the certification criteria represents a lot of different issues I mentioned already. So you're preserving for the present and future users of information. And that means you have to have an archive that is trustworthy for your users. And the criteria demands a defined and transparent mission, ensured infrastructure, staff responsibilities, and so on. So the kind of decision management is supposed to decide. You also have day-to-day documentation of workflow decisions and metadata, awareness of legal issues regarding copyright or data security, and what kind of preservation actions you decide on. And finally, as already mentioned, cooperation, expert guidance within the digital preservation community, but also with regard to your target community is also really important. So these are my picture resources and references. And now we're doing a little question and answer session. So who's reading the chat questions?
I think there aren't quite yet.
Okay. So if we don't have any questions, we can
Yeah.
survey.
Can I just ask, just to stimulate discussion, what is the difference between preservation and curation?
Curation. Oh, it's mostly I would say definition. What kind of word you want to use. Curation, I would connect mostly with metadata. Yeah, that's the usual way I heard the word used. So it's more of the third level of digital preservation, the curation level, where you make sure that you have enough metadata archived or preserved with the content, with the object, in order to still understand it. But of course, if you don't have intact object, you also cannot understand it anymore. So it kind of covers this. But there's also the Digital Curation Center, which has this life cycle of objects, and they use curation also in context with digital preservation. So for details, I think it's interesting to look into this life cycle model.
Thank you. So, Katerina, we have a question from Sanjay. Thank you, wonderful presentation. Do you see any changes going forward due to AI in your field?
Okay, I feel that is very broad. At the moment, I would see maybe a change in that we have AI research data, which we also supposed to preserve, or which, because it's research related, it's interesting to preserve. With regard, it's very difficult. Maybe you can construct some solutions, but of course, artificial intelligence, as it works at the moment, it needs a lot of calculation power, and you have to have very specific questions you can ask it, and then it works with probabilities. So maybe some kind of probability, whether it selects the right format recognition. I'm not a scientist in that way. That would be work of someone else. I haven't heard anything about this discussion, if there's one in the digital preservation community, actually.
There is another question, and that is, can you explain the difference between content preservation and migration?
Content preservation, I think that was related to the second level of digital preservation, and it's more or less the same. So content preservation is the overarching concept that you keep the file. You can still render the file. You can open it and see the content. And one possibility to do that is migration. Another possibility is emulation. So these are different techniques, more or less. Okay. Yes, we should move to Uta's presentation.
Okay, thank you. We as well might skip the second survey, maybe to an end or to another possibility. So I'm sharing my screen and start with the presentation. So, okay, I hope you can see it all right.
Yes.
Okay, fine. So I think there's not much time left, so I will a bit hurry up. So I skip maybe the first lyrics about why actually research at ZBMIT, but maybe there's so much to say. ZBMIT transformed from a classical scientific library to a research center for information and data in life sciences. So we aim to support and strengthen research for its disciplines, ranging from medicine to biodiversity and environmental protection. To support research along the entire research cycle, we lay foundations for open science practices and new knowledge, and our work is based on 5 strategic principles, which you can see on the slide. Most importantly for us here might be to promote the open and fair reproducible research. Fair meaning here findable, accessible, interoperable, and reusable as guiding standards to ensure research data to move through the various stages of the data life cycle without hindrance and any loss of information. And of course, the 5th part, which we are doing now, we actually actively share skills and knowledge. So I continue with the second slide. As we heard before, digital archives are not long-lasting, and compared with printed books and journals, we have to handle a much faster rot, like bit rot, software rot, link rot, or disk rot. Now, but what is special about research data preservation? First, we have a wide variety. A research project may include variety of data resulting from experiments, measurements, data collection, surveys, and similar activities. Second, research data is produced for a special subject community, and each of them apply their own commonly used software and produce their typical file formats. Unfortunately, mostly proprietary. Third, the amount of data material can be huge. They may reach up to terabytes, so one needs to have the infrastructure to handle it. And the next one, very importantly, to understand data and reuse it correctly for further research analysis, there are specific metadata required, which describe the context and methodology in which the data was created. To get the digital preservation of research data started, we knew we had to develop necessary workflows and match and add metadata and configure our preservation tool Rosetta to ingest and manage the files. Katharina talked about this before. But we needed also data to start with and to develop skills. But we also knew it would be very time-consuming to focus on single research data projects or data sets. We saw, unfortunately, there's still a gap between the current research practice and the ideal world of digital preservation. In the ideal world, researchers would use open file formats, use common standards, would be engaged to be fair, and would practice good data management and documentation right from the start. Often they start at the end. Having that as a starting position, we look for partners and to gain a closer approach to our life science research communities and spread the word of digital preservation awareness. So we came into contact with the Leibniz Center of Agricultural Landscape Research, ZALF here in Germany. Bonares, as funded project, they host the Bonares Data Repository. And Bonares is a German short term for soil as a sustainable resource for bioeconomy. That's what they do. The repository contains soil-relevant research data taken from long-term field experiments. It offers support for saving, archiving, publishing, as you see here, and the usage of research data alongside open access and fair principles. Yeah, and all it still needed was a long-term digital preservation. So in 2020, we prepared the concept design and started this year as partners into a 3-year pilot project of digital preservation of Bonaré's research data. So to get an idea shortly how this repository functions, Bonaré's is a database for open use. It requires only a short registration. This slide shows a screenshot with a search result. I made a simple title search for soil. And here you see the metadata, which are here in different categories. You can have it in German and English. Bonaré's uses international recognized standards, DataCite for describing research data, and Inspire for geospatial data. The user of the repository has the opportunity to download and to choose the destination format of the data, which you see here, the download file. And you can choose also one of the 4 different coordinate systems, the one the user wants to import the data into. Just so that we will preserve all the metadata, which is here completed together with the data objects. So when you want to download those, a link will be sent to your registered email address for downloading and is available for 24 hours. Now the big question, what shall be reserved? Bonaré's holds several file formats, as you can see on the slide. In the concept phase, we analyze the data and their structure on the basis of sample data sets. In consultation with SALF, we understood that the essential research data are archived in CSV and XML data. All other data would be additional information, relevant but not essential. We therefore agreed on preservation planning of the CSV and XML files, and all supplementary materials will be included without any obligation. For the pilot project and the development of workflows, CSV and XML are good formats to start with because they're interchange formats and easy, more easy to migrate. You will see. We have no practice yet. So next one, risk and preservation management. Katharina explained already before this more in details. Here on the slide, you see what preservation levels relate to the currently discerned preservation actions for the pilot project. But I may explain a bit more here why open formats, or at least widely used formats, are important. If a very specific proprietary format, for example, of a laboratory software is used, possibly after 10 years already, it cannot be opened in the archive, since software is not available anymore, or the software license is just too expensive and too difficult to obtain. Accordingly, migration will be difficult, if not impossible. If it's a rare specific format, there might also be no migration tool available. Of course, it may be possible to hire a software developer to develop one, but would it be really sensible for just a few files? Unfortunately, digital preservation is a cost-benefit consideration until we live in the ideal world of open formats. The pilot project aims to automation of proven workflow to transfer the data and preserve the structure of the objects. In short, as you see here in the slide, the workflows move the data step by step from the repository to the preservation software, Rosetta, and back again in case of a trigger event. What you also do is organizing future reuse. But when I think of it, the title of the slide should actually be communicating future reuse, since there's a lot of exchange needed and things to agree on between us as pilot partners, reflecting on the further development of our preservation and repository practice. For our exchange, we will be using the tool GitLab. And between us, the repository, and the data producer of today and possibly reusers of the future in form of data workshops. And where we also put emphasis about data management plans and transversal repositories. But we also need to monitor together with all involved which file formats, software, technology, and standards might be commonly used later and today are, and what the difference might be, and to apply this to our preservation and risk management. So, the conclusion. The Bonares pilot project is a great opportunity for us to develop skills to digital preserve research data. It's also the logical next step for a repository to preserve their research data on a long-term basis. As partners, we selected content and agreed to focus on the most essential data, CSV and XML. Automation is aimed at to incorporate the data into the preservation software and return lost data back into the repository. This will be tested. And last but not least, the project may be end after 3 years, but to be fit for future research, digital preservation needs continuous funding. Thank you very much for listening.
Well, thank you both for your excellent presentation and the insight what you are doing. Are there any questions? I think you mentioned that it's a lot of time you need for this kind of work.
There are no questions in the chat, Ursula, so.
Okay. So, but perhaps there are some questions in some minutes, in a few minutes. I have a question of time because perhaps you can tell us about something about the team, how many people are working, or what kind of professional we need to have this support and do the things you are doing.
Okay, I will start. We are 5 people at the moment, and so we have several different librarians, but we also have a software developer who is helping us with the automation of the workflows. As I mentioned, the pre-ingest step, so preparing the objects in order to have them Rosetta conform or whatever software you use, this does take a lot of time. What also takes a lot of time the contact to the data producer and to find out what exactly we're getting, where we're getting the metadata from. The rights might also be complicated in some cases. So if you have some kind of old contracts, maybe with the publisher, you have to check whether you're actually allowed to do digital preservation. So yeah, there's a lot of work that goes into the workflows for a specific collection before you even start actual digital preservation.
Thank you.
I have a question, Ursula. I have a question from Q&A. This is from Madia Rani. While curating the data, do you consider the data sensitivity too?
Yes, definitely. Actually, with regard to the European data security GDPR, this is become more relevant, but of course it's still in general relevant. And at the moment we are preserving open access publications, so this is not an issue. But digital preservation is easier to do if you have a very early contact with the data producers. And in case of medicinal research data, of course, there's an issue with data privacy if you have some kind of patient's data. And we are in contact with the researchers at ZBMed and in order to find some kind of solution. In some cases, you might preserve the data, but you cannot publish it maybe, or you have some kind of anonymization of the data. That's also possible. So this is still in the future, but yeah, we're thinking about it, how to solve this challenge.
Thank you.
Ursula, can you, are we rushing for time? Or there's one comment here about the appreciation of preservation of audio-visual materials. Can one of the presenters for a minute or two talk about preservation of audio-visual materials? Or is it too complex to sum up in a minute?
We actually don't have experience with that yet. So our cooperation partners do. But at the moment, we preserve text and image files and publications. So we can't really tell you a lot about this. There's discussion in the digital preservation community, and yeah, you have to check some archive that is doing active preservation in this with these files.
Yeah, thank you for the idea. And this committee will take this kind of request into consideration and order perhaps organize future sessions and to answer these questions.
Yeah, actually we have some publications with audio materials, so we come back to you in 1 year, I think, the next future. So we have 3 o'clock here in Germany. So I think the 60 minutes we have planned rushed away. Thank you very much for your questions, for attending this webinar. Thank you very much for all the team behind us or in front of us to manage this webinar, online seminar. Thank you for you both, Uta and Katharina. Yeah, thank you very much. And we expected to see you in the next IFLA webinar from the IRL section. Have a good time, evening, morning, day, wherever you are. Bye.
Thank you,
Thank you
colleagues.
for the opportunity.
Okay.
Bye.